So let's see that we get the confirmation on the recording. So I tell everybody, as you should, that we just launched the recording so everybody's aware of that. Hand over to you, Dave.
Great, thank you, Peter. I'd like to say welcome to everyone. I see right now we're at 104 participants, so that's just wonderful. It's nice that all of you have joined us this morning or this afternoon, wherever it may be. But welcome to HCE's second webinar in collaboration with the Heat Academy. And today's main topic is innovations in waste heat recovery. We have three themes: the value of waste, heat from waste to resource, and no time to waste. So I'd like everyone to please keep their questions to the end. There will be a few minutes allocated at the end for questions and answers. But along the way, if anything comes up and you do want to raise a question, please make use of the chat function, and we'll either answer it as we go, or one of the panelists will answer, or someone will answer. If not, we'll get back to you at the end of the webinar and make sure that all questions are answered. I'd like to ask you to please mute your microphones. The session will be recorded, as we just talked about, and it will be available early next week. We'll send it all out to everyone who's registered, everyone we keep track of on the Teams platform. The presentations will also be available, and we'll send those out to everyone who registered, or send a link out to everyone who's registered so they can access them. And I think that's all the housekeeping things. So I'd like to start things off. We have a lot of content for you today, so we'll move right along. And I'd like to welcome Jeff Cowan, our CEO, HCE CEO, to welcome everyone and start the webinar. Jeff?
Good morning, everybody, and welcome to the second event in our education series that's spotlighting local and international solutions and technologies that create healthy, productive, and sustainable communities. I'm Jeff Cowan, the President and CEO of Hamilton Community Enterprises, and I'd like to begin by thanking the Hamilton Chamber of Commerce, our presentation partner for this event, and the initiator of Hamilton's Waste Heat Recovery Project. As David mentioned, our theme for this event is Innovations in Waste Heat Recovery, and will be presented in three parts, beginning with the value of waste heat presented by Dr. James Cotton of the McMaster University. Dr. Cotton is passionate that the heat wasted into the atmosphere is a resource that we can no longer ignore. This will be followed from waste to resource, being presented by Peter Anderberg, who will provide us with global insight into how waste heat is being recovered to offset the fossil fuels used for building heating in Sweden, ultimately reducing their carbon footprint. Concluding will be HCE with a call to action: no time to waste, highlighting the local opportunity along with framing a sense of scale associated to developing a transformational heat recovery initiative here in Hamilton, supporting Hamilton's growth and 2050 net zero vision. Before I introduce our next speaker, I'd like to say a few brief words about Hamilton Community Enterprises, followed by a special thanks to those attending. HCE was founded in the early 2000s as a result of the deregulation that was occurring in Ontario energy sector at the time. Wholly owned by the City of Hamilton, HCE has grown into becoming an integrated utility solutions provider spanning the non-regulated energy and telecommunication sectors. I like to say we are an expert at developing community networks. HCE owns and operates district energy networks, distributed energy resources such as solar PV and combined heat and power systems, along with mission-critical internet, cloud, and metro area fiber networks. HCE has become an expert at delivering the kilojoules, the kilowatts, and kilobytes that power our communities. Now, let me give thanks to the many guests, international guests and local, who are participating today, and welcome to Hamilton. The elected and municipal officials who are present, and a special acknowledgement to Grow the Good and its founder, Adam Ayers, a not-for-profit who's helping us connect the dots with various partners locally and globally. The local promotion partners who have helped us drive awareness in today's session, That includes the City of Hamilton, the Bay Area Climate Change Council, Hamilton Industrial Environmental Association, the Hamilton Oshawa Port Authority, Quest Canada, McMaster University, Sustainability Leadership, the Atmospheric Fund, and Clean Air Partnership. So at this time, it is my pleasure to make an introduction to Mary Nash, the Interim President and CEO of Hamilton Chamber of Commerce, who has been involved in the Industrial Waste Heat Recovery Initiative for over 3 years. And an interesting point of note, Mary is the first woman to act in the role of President and CEO of the Hamilton Chamber in its 175-year history. What a great accomplishment. Please join me in welcoming Mary.
Thank you so much for that warm introduction. So good morning, everyone. My name is Marie Nash, and I'm the Chief Operating Officer, but now Interim CEO with the Hamilton Chamber of Commerce. And I would like to thank everyone in attendance for their ongoing interest in pursuing industrial waste heat recovery solutions for our community. And would also like to recognize our colleagues at Hamilton Community Enterprises and the Heat Academy and Nordic Heat for their ongoing support and collaboration. For over 175 years, the Chamber has been championing the local business in our community by facilitating connections and collective action to strengthen the economic engine of our community. Our policy and advocacy portfolio includes long-standing commitments towards advancing the decarbonization of local industry through investments in technology innovation that will support the longevity of Hamilton-based organizations facing significant carbon reduction targets as Canada pursues net zero emissions. Given the concentration of industry along Hamilton's industrial bayfront area, the Chamber and its partners identified opportunities to study the waste heat recovery and reuse potential, and further explored this potential in our TAF-funded study that was released last year. Significant opportunities for waste heat recovery were identified, and this sparked a new partnership idea between the Chamber and Hamilton Community Enterprises to explore potential district energy expansion solutions to redirect this waste heat into productive uses while simultaneously reducing overall emissions. Today, we continue to work together as we collectively explore creative solutions to pressing matters affecting the long-term economic prosperity of our city. The pursuit of net zero emissions will require creative solutions and collaboration among a variety of partners and as industry and innovation come together. We believe that Hamilton's district energy and waste heat recovery potential demands significant attention, not only as a mechanism to foster local collaboration, but also to facilitate job creation and retention. We're excited about the significant community interest this initiative has garnered and look forward to the work ahead. Thank you, and I'll now pass it over to Peter.
Thank you, Marie. And so I will, first of all, make a brief recap of what we discussed last time at the last session to pick up for the conversation today. So please allow me to share a few slides. And by the way, I'm Peter Anderberg, for those who didn't meet me last time. I've been in this sector of energy, district energy, for the past 20 years. And since 10 years, I run a group of companies involving Heat Academy, which is a not-for-profit, and also Nordic Heat, which is also a not-for-profit. So, but I'll share my screen, and we're going to make a very quick recap of what we discussed last week. I hope that's visible to everybody. Otherwise, please shout out. So what we focus on, and we started this with this slide last time as well, what we try to achieve, the challenge with projects in this sector of implementing solutions to decarbonize heating and also cooling, by the way, is that they often get stuck in the preparation stage. It's very difficult to take a project into delivery. There are many blocks in the way, and the challenge is to form these blocks to a bridge so that we move into delivery. And the main blocks we need to address are the cost of a project, the risks, and to some extent also the revenue model to make it commercially viable. And this, with our various set of services, this is what we try to address. And today we are operating from this platform of training activity. So I'm going to focus on that. So last time we looked very much on the question of why does it make sense to implement these solutions? We will, to some extent, cover those questions today as well. We also looked into the technology you can apply to capture heat, to distribute it, and to manage a heating system in a smart way. I should point out that the recording from the last session is available, and also the presentation slides we used last time for those who are interested. In brief, what we touched upon on the question why is that heating is a very big chunk of the primary energy consumption globally on the Northern Hemisphere. In an average city, heating is almost 50% of the total energy demand to make the city, to keep the city going. In most cities across Central Europe, and I believe also in North America, this energy comes from gas, natural gas. In many cases, you have a dependency of gas over 90% to heat buildings in cities. And that gas and that dependency on gas for heating makes it that heating actually represents between 30 and 40% of total CO2 emissions in any city. So that means that this is quite an important topic to address if we want to address climate emergency. What's happening right now in Europe is that we have two other factors very strongly driving decarbonization. They are both related to gas. Half of the gas being consumed in Europe comes from Russia, so obviously that has become a big driver in recent months to try to see how can we get less dependent on that. But also an effect of that is that gas prices have soared in the past year to enormous, very, very high levels. This has happened before, and I'm going to come back to that a bit further down the line in today's sessions. We had a crisis in terms of energy also back in the 70s. What was done in Sweden and in other Nordic countries was that we started to build heat networks. Heat networks were built because they could address the energy security issues that were created by the oil crisis. But over time, we discovered there were lots of other benefits by building heat networks in terms of balance of trade, in terms of creating local jobs, in terms of improving the air in a community. So it was started by energy concerns, security concerns, but then as we move forward, we saw other benefits. And it has also proven to be a very profitable investment if you look from a commercial angle. Finally, last time, we also touched upon the different technologies on a very high level, but still different technologies available that you can apply. What are the best practice? And again, we're going to come back to that in future sessions. Today, the focus is we are moving more into how, but to be able to do, and particularly we're going into the stakeholder involvement section. And to get stakeholders involved, we need to be able, in a better way, in a very sharp way, describe why does it make sense to make these investments. So we need to bring the conclusions from last session into this one, and to be able to make a good story why district energy is a good thing to do. So this is basically what we're going to focus on later on in this section, which I am responsible for. But before we move into that, I'd like to introduce you, Jim, and I go back to the screen, to move back a bit and from a higher level again, look at the value of waste. So I hand over to you, James.
Thanks very much, Peter. Can you see my screen okay?
Not yet, but now we see them.
Excellent. Okay. So let's see if I can do this. Okay. So hi, everybody. I'm Jim Cotton from McMaster University. I'm the co-director of the Institute of Energy Studies. And I'm representing a cooperative of partners, 20 partners actually, in our community in Ontario that I've been working with for the past 5 years on integrated community energy and harvesting systems. And I talk a little bit about the value of waste heat, and I don't use that term very much anymore, but the session is about waste heat. I talk about energy harvesting. This is a resource that's within our community that we need to understand and use. So climate action requires certain actions that we need to start taking, and Peter mentioned them right off the bat. Is our buildings have significant carbon, 20 to 40%, depending on the type of building. In Ontario, we live in a very cold climate. Right now, it was -20 last night or so. And the solution could be the electrification of heating. But what does that bring into play? That brings into play a 2 to 5 times increase in electrical demand. And that depends on how you do it. And I'm going to talk a little bit about that. So that is happening at the same time as we're electrifying vehicles. But another problem is we waste more energy, more of our primary resources to the environment than we actually use. So if we start to think about how to integrate this and look at these challenges together, we have actually a pretty good solution towards tackling this problem. And this is a slide just to give you an idea of where we are and where we're going. Okay, so the black line here is our electricity consumption in Ontario. Okay, it peaks in the summertime. The red area here, that's our heating demand. It's cold. Our heating demand far exceeds our electrical demand. Now, if you look at our peak electrical demand, it's about 80,000 megawatts. And that's sort of those days when we have -30, -40 degrees Celsius. Compare that to our peak, summertime peak, we're at 23,000 for the last few years, right? Now, let's electrify heating, okay? And I'm not going to get into this too much, but we have different COPs. So here's our average COP for, say, an air source heat pump with a seasonal average of 2. Here's an average COP of 3. So this would be a typical installed ground source heat pump. And then here's a higher one, a COP of 7. So if we used waste heat resources, what would happen? Now, that's a challenge. It's a huge challenge in itself to increase our electricity capacity up to 50,000. But the real challenge is increasing our peak. Okay, so if you look at the coldest day of the year, how is a heat pump, an air source heat pump, going to perform? It's going to have a COP of 1, essentially our electrical resistant heating. We have now almost have a 5-fold increase in terms of our peak winter demand. So this is a challenge we have to address and understand. It's not just the amount of energy, it's the peak energy that we have to start thinking about and addressing, and we have to do that now. So, by the way, this doesn't include EVs. So here, there's an issue here is we're doing this across all sectors. This doesn't include industry. So what happens when we include all of that? Well, the other thing is we waste. We waste a lot. This is Ontario. This is sort of old right now. Unfortunately, Caesar doesn't update their visualization reports anymore, which is really sad. But if you go back 2013, it hasn't changed that much aside from this gray line of coal is completely gone out of our energy sector. We basically used of primary resources 4,000 pentajoules. Okay, what does that mean? That's 100%. Let's just keep it at 100%. We used about 33% of that. Okay, the rest was lost to waste heat. So if we look at that and we break that into sort of numbers and give some relationships, those Zinke diagrams, essentially, if we were able to reuse some of that waste heat, what would that mean? How much is it? What is available? We need to start mapping this. This was done from a top-down approach with our research partnership on the Ice Harvest project. And it gives you an idea of the total waste. So if you look at from industrial waste, it's definitely the highest opportunity. Okay, so it's commercial. So we're talking 64 terawatt hours of thermal energy, 30 terawatt of thermal energy. And in our study, actually, we focused on these ones because these are going right into our community. These are directly assets that we can use right now and start to decarbonize our heating using these wasted resources. You sum all of this up, and we have 130 plus terawatt hours of wasted energy already embedded in our community. And our heating from natural gas right now is about 191. You know, you're talking right there. If we could harvest 50% of this, just 50%, you're reducing that carbon emissions and going directly to our targets, essentially exceeding our targets by 2030, 2035. So first off, what you would do, and this was highlighted in the industrial waste heat recovery project by HCE and Taft and the Chamber of Commerce, is the high quality, good energy you use on site. And I went back to when I started at Mac, and I remembered this paper, and I remember these payback periods. And I don't know if you remember, in Ontario, gas used to be expensive. 43, this is the commodity price, 43 cents. We've been averaging from 2010 to 2020 about 10 cents. And these were the payback periods. Okay, so 1 to 2 years, about as high as 3 years for some. Most of them just a simple heat recovery projects. You know, it's a heat exchanger and some pipes. That's what it is, maybe a pump. So it makes perfect sense. Now, this payback period got a little bit worse. And I did some projects with some big industry partners in Hamilton. And these numbers started to creep up to 2.5 to 3, and it was harder to do. But what we did is a full energy balance on the entire plant. And what we found was, yes, there's high quality energy with good payback periods. And what really incentivized them was not the payback period, because the huge capital cost up front for some of these projects, but what it was the increase in productivity that led to the better resources allocations, better quality in terms of their products. That's some of the things you could do with heat recovery. One thing we did for a strip mill was we investigated preheating their ingots before they went into the furnace. So instead of keeping them and letting them cool down, keep them at 200, 300 degrees Celsius. Right off the bat, it's about between 15 and 20%. Good payback period, about 3 years. But what really started to sell them on that was the increase in quality, the increase in productivity. And in fact, they hired the student that was working on that project to continue working there. Another one I'm going to plug is my own company. So look at the commercial side. Think about how much we waste. And this is far worse than any other process that we talk about. Look at our cooking processes. Pizza, for example, is the company we partnered with, and they waste 90% of the natural gas. So 50 cubic meters of natural gas a day, every day, summer, winter, fall. And 90% of that goes up the chimney. We've developed a system that integrates their electrical system, their hot water system, and we even preheat the air going to the system. We've reduced the consumption to about 43, and now only 40% of the waste goes up the chimney. This has a payback period of about 2 to 3 years. Okay, and this is 2 to 3 years of a prototype costing, so not commodity costing, not high volume costing. Still a challenge for them to do. But what we've proposed now is a rental energy sharing model. And this is really taken off. So we look at this, we have a 10 to 15 year lifespan of the product. If we are able to install it for free, this is something that they really think is going to happen. And this is servicing markets that typically can't afford high quality, high expensive materials to do this energy harvesting. Now, what is motivating this? Well, we don't have the same problems as Europe. Our cost of natural gas is fairly inexpensive. And the number I showed you before, the 2006 numbers with the sort of 1 to 2 payback period, we're only now in 2025 going to be hitting that. And that's really thanks to a carbon tax. So if you're stressed about a carbon tax, just go think about 20 years ago before fracking and the cost of energy then. Here's our projected carbon tax. Here's our delivery charges with inflation. Here's our projected natural gas commodity costs. It's not expected to go up much. Here's our HST. Thank you. And here's another price on carbon. So we're looking at right now essentially doubling the cost from where we are in 2030. And we have some significant motivation. If you think about a 1 year payback period in 2025, using the 2006 numbers, we're getting into fractions. So right now, it just makes sense to do that. But this also has implications on our home heating systems. And if we want to look at this and really target carbon emissions reductions, we have to think about how to do that. And I'm going to give a very brief introduction. Many of you probably have seen presentations from me on the ice harvest system. It's a distributed energy resource. It's essentially, we call it a microthermal network. It's an integration of multiple DER assets, so heat pumps, CHP systems. Right now, we're using natural gas. In the future, we could use solid oxide fuel cells that run and have carbon capture, still on natural gas. We could use other technologies, biomass generation. But the primary focus of this is the energy harvesting. Now, one thing I didn't mention, in my studies when we did some of the industrial partners in Hamilton, even with the increase in harvesting on site, the reuse of the high quality energy, they had more energy they could ever use. So why wouldn't they try to sell that or get carbon credits and give that to the community to reduce the community's energy harvesting potential? And that's sort of where we're going right now. We also need controllable loads. And I'm not going to talk much about that, but as you get more renewables, you get more curtailment. And essentially that's electricity that we don't even, doesn't even reach the wires. And I think ultimately there's a huge benefit of bidirectional vehicles and all of this. But the objective really is to minimize greenhouse gas emissions. And I'm going to say that's really the opportunity. So this is a rendering of the iService system. It's very similar to a 5th generation district energy system. It is much smaller. And the key difference is that we vary the temperature of the system. And therefore, by varying the temperature of the system, we can fuel switch on the fly within 15 minutes to half an hour from running a CHP system, say as a decentralized peaking power plant, and run this, say, during the day, like we do right now, following the grid requirements, not the site requirements. So you're offsetting central peaking power plants that are 42%, replacing that with something that is 80% or higher efficient, and delivering heat through a microthermal network. Now, these our goal is to export energy so we can support the rest of the community high intensity loads, especially as we start to electrify our vehicles and geothermal systems in the neighborhoods around us. So we could store some of this energy in short term. And then at night, when we turn off our CHP, what we would do is reduce the temperature of the system and then electrify heating using heat pumps. And these heat pumps, they could be bidirectional. Say for an arena that is constantly dumping thermal energy, we could be capturing that and putting it into our system. Okay, so we do direct heat exchange during the day, get rid of electricity. Heat pumps at the day increase the electricity from 2 to 4-fold. So now we have control. We're creating these loads. This arena could share energy with the pool next door. Or we have this community center. Community centers or libraries, they have data centers. We'll integrate the data centers. And maybe there are certain times that they are using energy to heat the building, or internally they're taking the energy from their data center, their waste heat, and heating the building. But if there's too much, give it back to the community. This is great in the wintertime, but what do we do in the summertime? Well, we have and have built the system is seasonal storage. And at McMaster, we have a 66 borehole thermal storage system. It goes down 7 stories, 30 meters in diameter, and we actually heat up the ground to 60 degrees Celsius during the summertime. Wintertime, use that heat directly during peaks. Now it's starting to reduce, if you manage this properly, this peak minus 40 degrees, minus 30 degrees Celsius day, and start to really integrate our different systems. And we're trying to replicate this. We've actually realized and this is really not even focusing on industrial waste heat, just to be clear. 1,100, I guess, 1,100 sites across the communities, focusing on big box stores, condo intensified areas, so apartments, restaurants, and community campuses across the province. Here's an example of a community campus. It's only 4 buildings, maybe 5, because we know that they're going to be building a couple condo towers just down the street. The diameter is less than 1 kilometer and about 1.5 kilometers if you include the condo tower. We have an arena that's dumping energy. We have a library that's dumping energy all the time, the cooling towers. Okay, so if we just put this microthermal network in play and we integrated this, what happens? Well, your business as usual carbon emissions is about 2,200. If you just start sharing energy, just from those 2 buildings, it goes down to 1,300. We add a CHP system, and we operate that CHP system as a peaking power plant. Okay, and we can play with that. Okay, we do it behind the meter, or we do it in front of the meter. we're reducing that down to 870. Now, we go one step further. Let's add seasonal storage. Now we're down to about 65% business as usual case. If we look at all of these sites in Ontario that we've identified through publicly available data, not even including industrial waste heat, just to be clear, we basically can reduce carbon emissions by 2.1 million tons. That's a significant amount. So this 65% less than business as usual. And if you look at our targets to 2030, that's completely doable. Now, how much is that? It's about 2 gigawatts of installed capacity, and they're on average about 1 megawatt size systems. It seems a lot, but that has already happened over the last 15 years in Ontario. We have CHP systems running 24/7 behind the meter, essentially, doing the same thing. Now, the next phase of our research project is really looking at mapping the additional opportunity around waste heat. And this is a study. Sorry, I have to put the reference on it. I forgot, or it didn't. It's not on this slide, but I'll have that in the slides when they're available, from Rotterdam, Netherlands, and I love it. It takes forever to explain it. Something I want to do eventually, but essentially this is your heat map. So the blue is the demand, okay, and then they're looking at opportunities for non-carbon based. So we have solar thermal roof collectors. They're looking at road collectors. They're point sources, and then geo exchange systems, all mapped to the city, and then looking at suitable storage. We need to start doing this in Ontario. We need to map out, in particular, our point sources and our loads and show where these networks belong. They don't have to be monstrous district systems. We have a built city, but if we started doing these microsystems, eventually they will connect. So the ice harvest system is actually a grid modernization asset, not necessarily a district energy system. It focuses on harvesting, it focuses on sharing, it focuses on electrification, but it's really a DER asset that I think should be controlled as a grid level asset. And that really brings us into this distributed system operating model, where a lot of it is controlled by our LDCs. As we get more and more DER assets within our communities, they need to be managed. And I think the most logical is through a distributed system model operator and our LDCs. It also provides resiliency. And I think there's going to be significant value to that moving forward. We've seen this in Western Canada, floods, fires. We've seen this in Burlington, so that's a key element. And then it provides auxiliary services, right? We're a dispatchable speed, dispatchable load. You have ancillary services such as power frequency control. So final remarks, energy harvesting is critical. So these thermal networks and realizing the opportunity to share your energy, which is, I know it doesn't really happen, sell your energy through microfinancial transactions, get carbon credits is key. I think we really have to step up our building code, and buildings need to be low temperature HVAC ready, so they can harvest this solar energy, this waste heat recovery. That's something I've talked to everybody about lately. We really need a national energy harvesting strategy. We need to map this community waste. We have to realize it's a resource and bring it together. And finally, just as a personal note, back in December 3rd, they came out with the pillars of climate plan for 2030. And the pillars were essentially net zero electricity, net zero vehicles, oil and gas caps, and emissions. They completely left out the building sector. And as Peter said, this is 30 to 40% of our carbon emissions. I think it seriously undermines our ability to meet these targets if we don't really start focusing on addressing these goals. Now, last, I just want to thank the team. We've had over 50 people work on this project, graduate students, postdocs, all the ones are highlighted are off in industry. Actually, I see a lot of the partners have hired these folks. They did all the real work. And finally, my industry partners, HCE in particular has taken a big leadership role, and Grid Smart City. But to be honest with you, it is amazing. We have all sectors of energy delivery, from district systems to thermal energy delivery partners, to geo partners, and our LDC partners all work together to make this project happen. Thank you. Peter, I'll turn it back to you, and you're going to go from waste to resource.
Thank you so much, Jim. A great presentation. Just a quick question for me. This report you refer to, is it available? Is it an open document or?
It's coming, yes. So we're publishing parts of it, and some of them are, Peter, so we can share that with you.
And we will make sure that those who are interested, you get a link to access it once it's available. Great presentation. Thank you, Jim.
Thank you very much.
So we move in to, as Jim said, from waste to resource, and I will take back the screen and kick off that section of the meeting. I will not show all these pictures, so don't worry. So there we go. I think this should be visible. As I mentioned before, we could see in the Nordic region building these kind of systems that we have been talking about so far, lots of benefits. They often start for a specific reason, and I'll come back to that shortly. But there were benefits that nobody could foresee, that it would be profitable, that it would be a way of generating jobs and keeping jobs in local communities, reinforcing the local, the competitiveness of local industries, but then also having social impact. And what is interesting now, we have an enormous energy crisis in Europe emerging, and the costs have gone up dramatically in recent months. Those who are connected to district heating in Sweden, at least, they haven't been affected at all by this, because all the heat, basically all heat used for heating the buildings, comes either from waste heat sources in terms of industrial waste heat or biomass, bioheat. But we can come back to that. So that's an interesting aspect as well, that this is a way of creating less of a turbulence on your cost of energy. To achieve, everybody wants these benefits, obviously, and everybody can see, we can understand, okay, putting a joint system in the ground will give benefits like the ones we've heard about and what we see here. The challenge is however very, very big to do it. The technical challenge is nothing. This has been done for decades. So the technology is, if anything, it's easier to do it today than it was before, because you have better equipment, better technologies. You can do it in a much more safe and much better performance and sustainable system. The challenge really in these kind of infrastructure projects, because that's what it is the stakeholder involvement. I prefer the way of describing it as stakeholder involvement compared to stakeholder management, which is often used as a term. I think involvement is exactly what you need. You need to involve different stakeholders, which in different ways can benefit from the system, and to make them understand the opportunities, to secure the buy-in basically from these stakeholder groups. And in the coming presentations, you will meet representatives from various stakeholder groups, and we have basically 4 core categories. It's the political institutions. We have obviously the end users, but also developers and real estate companies that we label customers. We have the general public. How do they regard these? We need to be able to explain why we start creating congestions in the street and putting pipes in the ground. We need to have an understanding why we do this. And finally, we obviously need the industry behind our back. We need to have finance industry who are able to sponsor or fund the projects. But we also, when we talk about the waste heat recovery, we need an industry that sees the benefit of this to actually, well, I would say share, but they actually sell waste heat, because that's what's happening in practice. To be able to see the point in this and to see the security that this is a long-term opportunity. It's not something that here today are gone tomorrow. So we need to have a very good story to tell. But even with that, we need to have a catalyst. And we can see it clearly today in Europe, and I come back to this picture. The climate change, and everybody has declared climate emergency and so on, but it doesn't really lead to practical impact that people are going out in the street and putting district heating pipes in the ground. Basically, this is what's happening now because it's getting very cold in many places in Europe now. There is a shortage of supply, prices are going up, and you can't afford really to keep the temperatures in the houses. And there is a risk this will happen again. And it's interesting because this is what happened in the Nordic region back in the 70s. History is back. We are back to where we were 50 years ago in Sweden. And this is a very short but personal story. This is the house where I grew up. When I was a kid, we carried logs up the stairs and we had individual fireplaces in different rooms. We didn't have even central heating. In 71, we installed central heating, and that was dramatic in itself. That was, people objected to that. Why would we need that? But we did that, and most Swedes did, and also in Finland. And then in our house, like in most others, they used oil to heat the house. And we ended up with another crisis. In those days, it wasn't Ukraine, it was down in Middle East. And the oil crisis and prices shoot up overnight, basically. And it became quite clear to everybody that this is not sustainable. Now, Sweden in those days were like most cities in Europe today and also in Canada, not using gas, but addicted to oil. Most buildings were heated by oil boilers. So we had to, and none of that was produced in Sweden. So we had to find another way. And what happened was basically a strategy that we still talk about today. We still advise people on, and it's still used. The first thing we did was to conserve, and I can't take any credit, I was a kid, but that happened at least to conserve energy, to do investments in energy efficiency in buildings, to reduce the demand for heat in the first place, to change windows and so on. So that was the first strategy, and happened all across the country and also in our neighboring countries. Parallel to that, there were initiatives taken to start putting pipes in the ground to create small clusters of heat networks, create what we call donuts in the industry, small donuts. And initially, these donuts were heated by a shared gas boiler or oil boiler, but over time, as you created more donuts, you could start connect the donuts to each other. And then suddenly you could start using bigger sources of heat. So over time, with this strategy, conserve, connect, convert, the house where I grew up now is connected to a large, huge heat network in the south of Sweden, using multiple sources of heat, primarily waste heat from different processes. And one source of the waste heat comes from a local company in the city called Chimera. And since several years, Chimera is used to send the waste heat out into the sea. Since many years, they rather sell the waste heat to the energy company in the city. And I will not spoil the story. Emma, I'll hand over to you. Emma, you are a representative from Chimera, and you know the story way better than I do, so I hand it to you.
Yeah, good afternoon, everyone. Emma Gunnarsson. I'm calling in from Helsingbor, Sweden. And first of all, thank you very much for having me. Looking forward to share some slides on the Helsingbor story. See if I can manage here. Hopefully you can see my slide now. Yeah, I'm going to talk a little bit about the example of Helsingbor, where we since 1974, since 48 years back, are collaborating between industry and the local energy company around what we call residual heat. I'm working at a company called Chimera Chemie, that is part of the global company called Chimera Oy. And I'm working as a manager for energy and sustainability. And just to give you a little bit of an idea of where we are in the world, Helsingbor is located in the very south of Sweden. They're marked with the red dot. And to the left here, you see an overview of our site in Helsingbor, and on the very below, the office. Unfortunately, I haven't seen it for quite some time now due to the COVID situation, but I'm really looking forward to going back there. Just a few words about Chimera, the company. It's a global company in the chemistry business. We are working against two customer segments, the pulp and paper industry and the industry and water segment. You have some financial KPIs there. We're about 5,000 employees. We have sales to about 100 countries. We have production plants in most continents. We actually also have some locations quite close to Hamilton, so you might recognize the name Chimera. We have production plants in Brantford and St. Catharines in Ontario. I was told that was in within an hour drive from Hamilton. We also have production plants in Varennes and Vancouver. So, for example, the Brantford plant produces hydrochloric acid that is delivered to steel mills in Ontario, and we also produce different type of coagulants that are used in municipal wastewater treatment applications. And the Helsingbor site that I represent is actually the largest one when it comes to production volumes within the whole company. I'm not sure if I mentioned it's a Finnish-owned company, so we are headquartered in the capital of Finland, Helsinki. So if we move back then to the Helsingbor site, here you can see us from a little bit of a helicopter view. Chimera has 9 different types of production plants within this area, but in addition, we have also invited several other companies to the industrial park. You see the logotypes there below. And our business model here is circular economy. And the remaining, the other companies here, they collaborate with us in one way or another. They buy excess heat from us or residual heat. We share fixed costs for the harbor or our infrastructure. We have railroad transport right into the site. And we also have a lot of material sharing where the product from one plant is then the raw material in the second plant. 1 million square meters, that equals about half the area of Monaco. So for Swedish terms, this is quite a large industrial area. Just to give you a little bit of a view of the energy situation here, our chemical production is highly exothermic. That means that when we let our raw material react, there are large volumes of energy being released. And that energy is then being recovered. So every year we recover about 500 gigawatt hours of energy mainly from exothermic processes. And this energy is used to heat our own production processes, thereby replacing natural gas. And this is done then for high temperature requirement processes. Where we can use our own internal steam instead then of natural gas. But we also produce our own electricity in a steam turbine, and we're self-sufficient to 50%. But our energy recovery is so vast that it exceeds our own consumption. And by that, we also deliver about 350 gigawatt hours of energy every year as district heating to the local energy company in Helsingborg, Sundskraft. And that actually equals about 35% of the sold district heating in Helsingborg. So it's quite a substantial amount. And here we have the district heating network. We saw that I think that was the same picture you showed, Peter, but this one is a little bit bigger than. The district heating network is not Helsingborg only, but actually several other cities in a regionally connected network. So in total, about 14,000 customers are supplied there with heat from this network. Now, if we go into a bit more detail of the industrial heat delivery here to the system, this is a duration chart. The y-axis is the energy production for the Helsingbor district heating network, and the x-axis is the time frame that we're looking at here. So as you can see, the district heating network was taken in operation in 1964. And in 1974, you can see that there is a green area that is replacing then some of the other heat production, and that is the Chimera heat. So we have been connected to the district heating network since 74, so 48 years now in total. Well, the top line here of the graph represents the total demand, and the different colored areas then represent the different energy sources used to supply the heat. And as you can see, in the beginning of the 70s there, our residual heat deliveries, they replaced fossil fuels, mainly oil and coal. And then the district heating network has developed. So the coal has been replaced with biofuel. And in 2012, I think it was, the light green area there, that is the waste incineration plant that was taken into operation. So as you can see, the industrial energy recovery here has quite an important role in the total network, and calculations show that we have saved 1.6 million tons of CO2 since 74. So thereby, by replacing then coal and oil and some natural gas also. For 21, the primary energy factor was calculated to 0.08, and the primary energy factor is a KPI that shows how much primary energy has been used for the system. So if that figure would be 0, then all energy would be recovered. But obviously 0.08 is a really, really good KPI for Helsingbor. Yeah, so Peter was mentioning this as well, but yes, for sure, it has been a win-win-win situation. There is a capex avoidance in energy production plants. Our 55 megawatt of heat delivery does not have to be invested, or maintenance has to be applied for that type of volume. So there is a huge capex avoidance by collaborating like this. It also provides stable and competitive prices to the district heating customers. And for us as an industry, it provides a very valuable additional income or a reduction to our production cost. And that is very important. We as a company are competing on a global market, and the competition is quite fierce. So if we can get an income outside of our core business to reduce our production cost, that is obviously very important. And not the least, then the GHG emission reduction that we see from this. Some success factors. What is the key to succeeding in collaborating like this? Well, we have always had profitability in focus, so this is not a PR project or anything like that. This is profitable for both parties. We are working with long-term agreements, that 10-year agreements. They provide us with predictability, and that is really important as we are both capex intensive businesses. It's good for us to know what will happen, or if we can lower the insecurity in our forecasts, that is very worthful for us. I would also like to mention or to stress out that residual heat is promoted by the Helsingbor city in their energy strategy. It is clearly written that the residual heat should be used if possible, and it is an important way of reaching the climate target of zero emission district heating in Helsingbor 2035. Well, as you can see, also large, what we call base load volumes, the 35% is valuable. We have also been working a lot with production planning so that we are adapting our production so that it will match the district heating network demand. As you know, that is actually a lot lower in the summer when it's warm, and it's a lot higher in the winter. So what we do is we try to plan our production so that we have a high production rate during winter and then store our product storage, and then to be able to go down a little bit in capacity during the summer. So this adaptation then is also, as I see it, a success factor. Otherwise, we have a high security of delivery, and we have communication along all or different types of levels within our in our companies. The operators on both sides, they have very high mandate to act and run the daily operation, but there is also a strategic communication, and this is required because the surrounding changes, the surrounding and the world around us is a lot different now in 22 than it was 2 years ago, or it was 10 years ago. So to have these forums for strategic communication and to develop new ideas and work together is extremely important. And I think that was all I had to say for now. If there's any questions or thoughts, feel free to contact me or Peter, and we'll try to get back to you.
Thank you so much, Emma, for this great presentation. And I will immediately hand over to, should we call him the customer of you for the waste heat? The energy company. Without a local energy company having pipes in the ground, you can't do this, can you, Göran?
No.
It takes a pipe network to make a city.
You need the district heating system to make this work. That's for sure.
So most welcome, Göran. You're representing Öresundskraft, who is the municipality and energy company in the city of Helsingborg.
Right.
Hey, Emma, I have a question. Great presentation. Is there time for a question?
Thank you.
Do we have time for a question?
Peter, that's a question for you.
You're muted.
Oh, must be.
I think, Dave, we have agreed we take questions at the end, or what's your view?
Yeah, Adi, if we could just put that off to the end, and if not, we can do it in writing, but
Sure.
Don't want to miss your question, but we've got a lot of content and time is passing. So,
Understood.
So if you put it on the chat for the time being, it would be great, and then we make sure we keep it in mind.
Okay, thank you.
Super, thanks. I hand over to you again, Göran.
All right. Okay. Yes, let me say a few words. I mean, Chimera and Öresundskraft, we are partners since 1974 and even before that. And it's a great partnership that has meant a lot to Chimera, to Öresundskraft, to the position of district heating, and naturally to the citizens of Helsingborg. So it's something very valuable. Now, let me see here if I can do this right and share just a few pictures with you. here's a short background to Öresundskraft. Now, it's important to realize that we are owned by the city of Helsingborg. We are a municipal energy company. So we're not private owned. We almost became private owned. I'll come back to that. But we are old. We are founded 1859. We started with city gas or synthetic gas, as it was called once upon a time. We're about 400 employees and 260 million euros in turnover, something like that. Around 100,000 customers, give or take. Now we work in various disciplines within the energy field. District heating, district cooling is one of them. We own the electrical grid in our part of Sweden, own and operate and maintain. We work with gas, not so much nowadays, but there's still customers who wants gas. We have been very active in building up a system for charging of electric vehicles. I can tell you as a piece of fact, we helped electrify one of the ferries crossing over to Denmark. It's a 10 megawatt charger. That gives you an idea of the size of it. So district heating wise, we have been doing this for a long time. We started 1964. The total length of our district heating system is something like 560 kilometers. We deliver approximately 1,000 gigawatt hours per annum. And as you heard Emma talk about a third of that actually stems from our cooperation with Chimera. I should say that I'm not an engineer. I work in communication. I've worked with public relations and communications for many, many years now. And for me and for us as a company, stakeholder relations are very important. And let me just give you a few examples. And once again, this is not going to be a communication course, but this is where your communication starts. You have a number of target groups that you want to talk to or reach to or interact with in various ways. But I've selected just a few here, and let me give you an idea of the kind of interaction and the importance of various groups. First of all, the city of Helsingbor, and as Emma mentioned, the city actually specifies district heating as a base for heating. It's in the building codes when the city expands into new areas. Then the customers may connect or not, but there should be a possibility to connect. And once again, as Emma mentioned, it's part of the energy plan in the city. When we do expand, we need to make holes in the ground. We will disturb traffic. We will disturb a lot of things. So planning and communication together with the city and the people that handles streets and traffic is key. I would say we meet them every week and talk about what's next, where do we want to dig and how long, etc. And of course, as we are owned by the city of Helsingborg, they're taking a keen interest in our financial reporting, investments, and expansion plans, etc. So there's a tight cooperation there. Then we have customers, and we have customers in various businesses, various industries. I've selected two specific names, and one of them I'm sure you're aware of, Johnson & Johnson. They have a subsidiary in Helsingborg called McNeil. They make, among others, chewing gum when you want to stop smoking, nicotine chewing gum. They have been working together with Öresundskraft for many years in reducing their carbon footprint. And 4 years ago, Johnson & Johnson Corporate awarded McNeil in Helsingbor the first ever certificate of being carbon-free, a carbon-free manufacturing site. And that was the first within the entire Johnson & Johnson group. And this was, of course, a source for great pride for McNeil, for us, and for the city of Helsingborg. But more importantly, it actually resulted in an expansion of the manufacturing in Helsingborg. So McNeil was awarded something like $25 million in expanding their production. And that's a direct result of district heating and district cooling. Because without it, they wouldn't have been able to get that award and reach the numbers they did. So that's one. Svenska Retursystem, very Swedish, two Swedish words, but they wash the plastic bins you see there on the right. And it's a fabulous system. When you distribute food stuff and vegetables to supermarkets in Sweden, you use the plastic bins that you see there. Those bins are returned to Helsingborg and washed, hot washed, relabeled, and then ready to be used again. They wash close to, I think the latest number was 600 million bins every year. They used to do it with gas. They heated water with gas, but for, I guess it's 8 years now, they switched to heating the washing process with district heating, which in turn resulted in lower carbon emissions and, of course, better numbers in their sustainability reporting. And those are two, I think, good examples of the competitiveness that you can reach when you work with district energy systems. So we're talking about stakeholder here. The public, well, for once, in our part of Sweden, we have the public are customers. I mean, they are connected to our electrical grid, they are connected to our district heating, etc. So they are primarily customers and treated as such. But they are also voters. Remember, we are owned by the city of Helsingborg. 3 years ago, something interesting happened. The city was approached by a company that wanted to buy Öresundskraft. They wanted to buy us, and that resulted in a preparation for a sale. And once the world got hold of this, there was actually a bidding contest. There were several interested parties who wanted to buy Öresundskraft. And the price was staggering. I think the city was offered $1.4 billion for a company. Huge money. And the majority of the politicians said, yes, we want to do this. And the public said, no, we don't want to sell our local energy company. And it resulted in a public vote. I think that's the word, when you let the people vote. And
local referendum is probably
a
referendum. Yeah,
referendum. Thank you, Peter. Referendum. 52% of the citizens voted, of which 96% voted no to a sale of the company. And the result was, of course, that we remain owned by the city of Helsingborg. So the public are important to us, and I think it shows the power of having an energy company as a local source of your needs. Let's not forget contractors. We spend something like $10 to $15 million every year in investments. That primarily goes to local contractors, people who dig, who weld, who X-ray, who do electrical works, etc. So we generate both jobs and incomes and taxes, of course. My final example is, I actually have a picture of it, I think. Well, there's the referendum. This is my final picture. Another group of interested parties are other local energy companies. I think Peter may have shown this, or if not, he will. But we are actually connected to a much larger energy grid than just in Helsingbor. In 2005, we connected with the city of Landskrona, which is south of Helsingbor, and in 2015, we connected with Eslöv and Lund. So we are actually part of a 50 or even maybe 60 kilometer city-wide district heating network. And this enables us to send energy back and forth should there be a problem. It increases the uptake of residual heat, such as plants such as Chimera, not that big, but anyway. And it enables us to optimize our production for financial reasons. So with that very short presentation, I want to, I guess what I want to say is show the power of district heating. It can do great things. It can do many things. And that concludes my presentation, Peter.
Thank you so much, Göran, and I hope you will stay in the session in the background if there are questions. But if not, thanks for joining us. I know you're under time constraint. But it's great that you.
How do I leave this now?
You go to the up on the top. You have an X. I can take over your screen. I'll take over it.
You do it. All right.
I'll take over the screen.
And
that brings us, so that was Helsingbor, and that brings us to the next speaker, to Zibi down in Netherlands, in the Netherlands. And Zibi, you and I met the first time a number of years ago in Helsingbor. You were up looking at the district energy company in Helsingbor and looking at particularly the connection between Helsingbor and other cities, because you are and have been for many years now involved in a project of connecting the capital of the Netherlands, Den Haag, and a city called Leiden with waste heat installations in the port of Rotterdam. I will not spoil your presentation, so I hand over to you, Zibi.
Thanks, Peter. Yeah, I'm in The Hague, which is, by the way, our government is seated in The Hague, but Amsterdam is our capital. Yeah.
Thanks. Now I know that.
that's because in the past, The Hague used to be powerless, so that was neutral ground for all the big cities to convene and negotiate things. But anyway, yeah, thanks. What you see is an overview of, well, quite an ambitious plan or an ambitious project that is Warmtelink. I myself, I've been involved in this project for quite some time now. It's a project that is run by GasUnie. GasUnie is the Dutch TSO for natural gas. And well, for several good reasons, GasUnie has decided to step in this project with the objective to connect industrial the industrial area in around the harbor of Rotterdam, with district heating grids in the province of Zuid-Holland. What you see here is a nice graphic, of course. The big, I don't know, can you see my, no, you don't see my cursor because I don't present this. I'm going to steal your screen.
Please just take the screen.
I hope this works.
Yes, clear and visible.
And do you see my cursor now?
Yes.
Good. Okay, so below we have the Rotterdam Harbor, which is in fact going along to the coast. So there's a lot of industrial activity here, but the project will start here in this area, and it will. The first chunk is in fact from the harbor to the city center of The Hague. And that is 700 millimeters piping and then going down towards the end in The Hague with 500 millimeters. It's quite a long shot. This distance is roughly 40 kilometers in piping. So that's quite something. And towards Leiden, this is still in advanced study. Would be even 15 kilometers longer. But the first bit, we have now recently taken the final investment decision. So this will really be built. What's more about to say? Yeah, the trick. Yeah, one of the things of this project is that in The Hague there are existing district heating grids, and they are fed by mainly by a gas-fired CHP, and the owner and operator of the distribution grid in The Hague wants to have another source of heat. So they want to have heat from the waste incinerators and industrial residual heat from the harbor instead of this CHP. So there is existing demand that can be that can take off the heat right from the start. And a similar situation is in Leiden. So right from the start, there will be there will be a kind of a start of capacity that is actually used, and that's important. And but the piping will be oversized for this existing grids because it should also enable new distribution grids along the way to be developed. So in the end, this pipeline could, as it is right here, could, well, at most supply 30% of the heat demand that from district heating grids in these areas. So in the end, it will not be sufficient to feed all or to warm all the houses. And that's not a problem, because there's also local possibilities for development of heat sources. And what we intend to do is to enable the development of distribution grids, because once there is a transport pipeline with sources connected to it, you can develop a grid, and while you are sure that there will be heat that you can buy, and then once those distribution grids are in the ground, then the following development of new local sources can take up with lower risk, because they know that there will be demand. So it is also intended as a kind of starting a jumper cable for new distribution grids. That's one of the intentions of the project. What is additionally, so as I said, it's also intended for new distribution grids that are not there yet, and we also don't know who will own them. So there's a lot of unknowns, and that's one of the reasons why this transport system should be open access. So any party should be able to use it. And it should not be like, yeah, I was first, so now for the next 30 years I can use it all by myself. That should not be the case. So and yeah, it's an open access transport system. That's a nice objective. I think it's a good objective, but it is a complicating factor when you're developing things like this, because normally you would Emma talked about the long-term agreements and contracts on supply and use, and yeah, of course, an open access system is not does not automatically match with long-term contracts. So that is that's quite a complicating factor. Another complicating factor is that very much unlike in Öresundskraft, in the Netherlands, the distribution grid companies are not owned by the municipalities. They are not even owned by whatever kind of a public party in Holland. And I don't count the Swedish government as a public party in the Netherlands, because of course they own Vattenfall, and Vattenfall is a distribution company here. But okay, that's really so we don't have municipal energy companies that of the sort of Öresundskraft. So the position of the public, and also the impression of the public of the intentions of all the parties involved, is very, very different.
Sorry, I'll break in there. Thanks for your presentation, conscious of time.
Yeah.
But it's a very interesting case which will have a big impact on other cities in Europe. It's a groundbreaking case, and it's so satisfying to see that you are actually putting the pipes physically in the ground now. So it's moved clearly into delivery. You talked about the political stakeholder, and before we move and hand over to you, John Ratburn, I have invited Carl Mosfeldt from the city of Gothenburg. As I think you've heard from both Göran and Emma's presentations, the political leadership and the long-term thinking is essential to make these projects, possible. That's the at least experience in Sweden. And Carl, you represent the city of Gothenburg, some 200 kilometers north of Helsingbor, approximately, an even bigger, second biggest city in Sweden, and obviously a bigger heat network. So that you can brag about that now. I hand over to you. You're on mute, Carl. You're on mute.
on Nymutenemo. So thanks for the introduction, and I'll try to be quite brief and maybe address a complementary angle of this, because I'm not particularly clued into the technicalities of heat district systems. So I won't talk about that. My role in the city is to accelerate the climate transition. So I lead what we call a climate transition office. My interest in this, which of course coincides with the speakers who've spoken, is to use these solutions to accelerate the transition away from systems that emit carbon dioxide. And we have a similar history to that presented at Helsingbor, and roughly a similar situation, give or take. And we now are looking at how to develop that even further with the kind of ideas we just saw presented from the Netherlands. In doing that, I've come to reflect a lot on the broader preconditions for developing these synergistic solutions, which is at the heart of it. And I was intrigued early on to see that the Chamber of Commerce from Hamilton was a key organizer of this event, because it kind of goes to the question of the broader institutional infrastructure you need to get these solutions in place. Peter mentioned the long-term political leadership and vision. And I suppose that's true, but I like to reflect on it in terms of the institutional preconditions. And when we look at the case of Gothenburg and the case of Sweden, I have a background here. Someone is talking. Is that just me hearing that?
Could we ask everybody to please mute the microphone? There is a background voice somewhere. Thanks.
So, when I look at this and ask myself, why did we in Gothenburg, like in Helsingbor, manage to get these systems?
A whole bunch of our VAV controllers or VAVs.
The ground now, I've got a lot of competition again.
To be reused. But then they've got all new.
Okay. Is that?
I think that should be done now.
Okay.
I've gone through the microphones.
Yeah, no problem. So, what is it that made us put us in a position to do this in the first place? And because of course this is about coordinating stakeholder engagement around shared interests, but shared interests that may not be possible to realize straight away. And the history in Sweden is of course very much shaped by it being a fairly homogeneous society, a different history from Canada. And that homogeneity was also institutionalized quite successfully through large civic movements. Trade associations, which played a very important part in my city, Gothenburg, but also other forms of civic associations, and of course also the big party, and in particular the Social Democratic Party, which allowed for a kind of coordinating infrastructure. So there were institutions that made sure that the right kind of conversations were able to be held within fairly trustful environments. And that's clearly one part, and it's often mentioned. One bit which I think is often receives less focus when you talk about Sweden, because it's not widely known, is that Sweden is in many ways a deeply decentralized society. And the constitution holds that the municipality have the primary right to tax the individuals. The large part of the tax authority lies at the municipal level, not the state level. And that means that the cities in Sweden are not generally credit constrained. And that's a massive advantage in this context as well, because it means that a lot of the necessary investments that are required to realize these kind of synergies can be carried on municipal balance sheets. And indeed, a lot of these initiatives can be taken based on municipal balance sheets. And furthermore, those balance sheets are credit worthy because they're backed by the tax authority, which means that these things can be funded in a relatively efficient way. And I think this is important when you try to distill what the learnings are between these different countries, because it's easy it's easy to miss where different kinds of solutions are needed and where they're not needed. I'm, for example, fascinated by how often Anglo-Saxon ideas are imported into Scandinavia without people fully realizing that actually these ideas are trying to solve problems we don't have in Scandinavia. A lot of the Anglo-Saxon debate is really about solving a credit constraint problem at the municipal level. And that's actually a problem we don't have in Scandinavia. So we can concentrate on getting done with other parts of it. But I think it's worth having these deeper questions in mind, or broader questions in mind, when, like a trade association in Hamilton, is trying to push these questions to the next level. Because ultimately, really, getting these solutions in place depends on the ability of a broader society to generate the kind of discussions across borders that are sufficiently trustful for people to be able to take risk on each other. And the less ability you have to raise capital centrally in the municipality, the more pressure is put on that question. And that's also, I suppose, efforts like yours, Peter, are so important, because there are essentially about weaving stakeholders closer and closer together so that they dare to look seriously at these questions. And I'll end with that, and thank you very much.
Thanks a lot, Carl, for that. And now I hand over to you, John. Back to Canada. You've done it. You're mute. You're on mute. I think you're on mute, John, but I can't hear you at least.
How about now?
Oh, now.
Okay. Good morning, everybody. John Rathbone, president of Rathco ENG. We are an Ontario-based district energy engineering consultancy, but we do work coast to coast to coast here in Canada. And I'm here to talk about some of the work that we've done locally to kind of take some of this international best practice and bring it into the Canadian market. So just quickly, for context reasons, we're a firm that focuses on third, fourth, and fifth generation district energy systems. And we also focus on the sources of energy, and we have specialized in all of the low and zero carbon sources, mainly wastewater energy, industrial waste heat, which is what we're going to be talking about, geothermal and biomass, but we also complement these types of primary disciplines with some complementary ones like energy from waste and biogas and various forms of solar. We work in 5 major markets. Obviously, utilities and municipalities are at the forefront of what we're talking about today, but we also work a lot with real estate developers, indoor agriculture, and colleges and universities. And I think the previous speaker was talking about constraints of capital. This is one of the reasons why I would say real estate developers is one of our largest markets, just because our municipalities are funded very differently here in Canada. Another thing that's important to know is that we do the entire life cycle of a project, from early pre-feasibility all the way through to detailed design and site supervision, operation, maintenance. But let's get into what we all really want to talk about, which is the Zibi project. So this is one of our very first projects. We've been working for them for 3 years now, and this is a Dream developer. The developer's name is Dream. It's kind of hard to work into a sentence, but the location is in Ottawa, Ontario, but technically it's also in Gatineau, Quebec. And they created their own district energy utility company called ZCU, or the Zibi Community Utility. And ZCU is a partnership between Zibi, the development, and Hydro Ottawa. And this created a very advantageous relationship so that they can leverage the opportunities that the private sector provides, but also gain access to public sector opportunities through Hydro Ottawa. So the Zibi system is a very unique system. It's let's start with the whole project. It's split by the Ottawa River with the I'll put on my little laser pointer here. The Ontario portion is this island plus this tiny little island here, and then this parcel of land over here is the Quebec portion. It's roughly 60-40 Quebec in terms of the 4.5 million square feet of developed space that is going to be built and in various stages of construction. It's about 34 acres of land that's being developed. So far, 6 kilometers of pipe has been designed, installed, commissioned across. It's going to be a total of 6 phases of infrastructure development, but that's been broken up into many micro phases, let's call it, but we will get into that in a future slide. And the primary sources of energy, at least from a heat perspective, is industrial waste heat. So there is a paper processing factory here called Kruger, and they make things like toilet paper and paper towels and napkins and other types of paper products. And their industrial process has a lot of waste heat. And up until the Zibi project, that heat was just dumped into the Ottawa River as part of their effluent. So like as their wastewater is being processed to generate their products, that hot water is just, once it's used up for their manufacturing process, it's just dumped into the river. Similar to the way we use hot showers. You know, we heat up our water in our houses, we take a nice hot shower, we get the direct benefit of that heat when we're showering, but then the vast majority of that then goes down the drain and is essentially wasted. The other part that's interesting is that the cooling source for this system is the Ottawa River. So technically this is considered a geothermal source of cooling. And what makes this really interesting and unique is that the industrial waste heat is intercepted at this location with a large heat exchanger facility, and then is directly piped straight into the central district energy system, which is located in Quebec. And that is done very deliberately, which we'll get to in a second. This is also where the intake and the discharge for the cooling system river water system is. This facility uses a combination of heat pumps to then upgrade the heat or downgrade the heat for cooling purposes to achieve different temperature profiles. And so in Quebec, it achieves an ambient temperature profile where there's a 5th generation ambient district energy system that distributes the energy to the buildings on this side of the river and uses heat pumps within the buildings to then either upgrade or downgrade the heat for heating and cooling respectively within the building. This is not the case for the Ontario side, and I'll get to why in a second. But in Ontario, this is actually a very unique system. This is a 6 pipe, so there's 3 individual loops. One is dedicated to domestic hot water, so we're supplying around 65 degrees Celsius. One is dedicated to cooling, so we're obviously in the single digits degrees Celsius for cooling. And then the orange pipe is actually a seasonal system. So this system during the heating season will provide space heating temperatures anywhere between 25 to 30 degrees Celsius, but has the ability in the summer to flip to a cooling system, which essentially triples the cooling capacity of the district energy system in cooling season. So this is a very unique approach. But the reason why this approach works here is because of the white line, which is the border. So here in Canada, we have provinces, and our energy systems are regulated and developed at the provincial level. So the price and carbon content of electricity in Quebec is different than the price and the carbon content of electricity in Ontario. So by utilizing heat pumps on the Quebec side of this development, the electricity being consumed is essentially has 0 carbon associated with it. And this is why you can go with an ambient temperature distributed heat pump model on this side, but you have to supply a 4th generation district energy system to the Ontario side, because if you were to put heat pumps on this side, then you would be using Ontario electricity, which now has a carbon content associated with it, which would then prevent the end goal of this being a net 0 carbon outcome. So it's a very unique situation, but you can see that first principle thinking was used to develop this concept. And again, it's a really, really great case study to utilize industrial waste heat. So this energy source was essentially being just dumped, and now it is being used to decarbonize over 4.5 million square feet of mixed-use development. So it's a really interesting project. Another part that made it really interesting is in order to get these 6 pipes into Ontario, we had to design and coordinate a lot of bridge crossings. So there's 1, 2, 3 bridge crossings, and then we had to work with some great structural engineers at WSP to develop a cantilever bridge support system here, because we had to suspend these 6 fairly significantly large pipes out over the river's edge so that we could then start to get them underneath this large Shodia bridge. So this has been a very great engineering challenge for us, but I think it really demonstrates what's possible and that we can do some really great things here in Canada. The site had additional unique site conditions that presented some great challenges that we overcame on this project, some of them being the very multi-phase nature of the project. We were able to adopt or adapt to the developer's needs so that we can try and minimize the amount of capital that's front-loaded at the beginning of the project, so that the capital being deployed for the district energy system is much better aligned with the deployment of capital with the development. We also mentioned the bridge crossings. The other thing that was very interesting was this island has no soil on it. It's essentially a giant rock. So this made excavating and some of the engineering details there a little bit unique. This is a picture of the seasonal flooding that occurred a couple of years ago. They had 2 100-year floods in 3 years. So maybe they need to update the definition of what a 100-year flood is. But this is definitely some interesting site conditions that have been navigated so far. And then the primary trunk portion of the piping distribution system is in a heavily trafficked road section. So there was a very well coordinated 3-month shutdown of that roadway that we helped facilitate from a district energy design perspective. So this is all to say, like, if we can do all of these things, then this is probably as hard as it's going to get in Canada. So a lot of projects will benefit from this as an example, I would argue. So we did a lot of things for Zibi, and we're continuously expanding our scope, I would say, as they learn more and more of what we're capable of. But we do full tender and construction drawing packages that are coordinated with the other civil buried infrastructure services. So although this is 6 phases, it's really been well over a dozen phases of tender and construction engineering deliverables so that we can facilitate that much more granular building by building approach, which the developer really appreciates. Again, we have very unique, you can see the pipes here suspended over the river, and there's a beautiful shot here with the Capitol buildings in the background. It's a very great location. And then you can imagine there's a lot of building penetrations that we've had to coordinate with structural engineers and waterproofing engineers to make this all happen. We also provide very detailed bill of materials and European procurement services. So this pipe shown in these pictures here is actually a special type of pipe that's meant just for district energy. It's called EN253. It's a European designed and certified type of product, specifically meant for a long life cycle. So when this type of pipe is designed and installed and maintained properly, you can achieve life cycles of well beyond 50 years. And so that's been a really big plus to provide this type of capability here in Canada. Unfortunately, the market is not large enough yet to justify local manufacturing of this type of pipe. So all of this pipe is actually imported from Europe. So we helped Zibi facilitate that procurement process. We're now transitioning into operation and maintenance advisory services to ensure that they are looking after their investments so that they get the value out of it over the long term, as well as advanced hydraulic modeling so that we can optimize and try and minimize the sizes of those pipes. So as you can imagine, infrastructure is not cheap. So if we can help reduce the scale of that infrastructure, then that translates into direct capital cost savings for our clients, which enables a much more sustainable business model to kind of align with the sustainable carbon outcomes that they're trying to achieve. So that's our Zibi project, and I'm happy to address any questions that come up as a result. Thank you.
Thank you very much, John, and I'll hand over to you, Dave.
Great, thanks, Peter, and I'll ask Ankur to take the screen. And I think one of the disadvantages of going last is from a timing standpoint. I talked about it as we began that we had a lot of content today to start with, and we've learned a lot and had a lot of things said. And as a result, we're very tight on time. So we've modified our presentation on the run, and we're just going to briefly go through some things. That's the disadvantage. The advantage is that a lot of the points that we wanted to make have already been made, and we're just going to highlight a lot of them, and it's helped us. Our presentation is really more going to be a summary of what we've talked about for the last 2 hours. So Ankur, if you can just flip the slide, it'd be appreciated. So everything we've heard and everything we've seen is this is a complex project. These sorts of things using industrial residual heat, and I really like that term, and thank our speakers for raising that instead of waste heat, but residual heat. Using this, it's a complex project. We're talking about a transformational opportunity. We're talking about multiple stakeholders, varied interests, high costs, infrastructure costs, uncertain policy. A lot of what and Dr. Cotton showed, as Jim showed, the effect of the carbon tax and how that makes a lot of these economics drive, and so there's a regulatory landscape involved. We've talked about ownership and governance models and differences that in different areas. So there's a lot of challenges, a lot of complexity, a lot of challenges. But why are we so interested in proceeding? Well, we're interested in proceeding because this project would allow us to reduce carbon emissions in building heating in Hamilton. And, you know, we've talked about it, we've used this cartoon a lot, but heating is really the elephant in the room when it comes to decarbonization. We've talked about in cold climates, building heating is 40 to 50% of the carbon footprint. It's easy to talk about electrification of cars. It's easy to talk about Teslas and it's solving all the problems on the roads. It's easy to talk about hydrogen. But really, we have to, in order to decarbonize, we have to address heating. And this project addresses building heating. The other thing that we like about this project, or is key to this project, is what we're doing is complementary to what industry in Hamilton is doing to decarbonize. So while the steel makers and other industries may decarbonize, they are still, their processes and the industrial processes that they use are still hot processes. There's going to be waste heat. There's going to be residual heat. They're going to change their fuel sources. They're going to decarbonize through those ways. But there's still going to be residual heat that can be used to offset fossil fuel heating in buildings. And that's why we like this project. And that's why we think this project is important and we need to move forward with it. Next slide, Ankur. So one of the things that we talked about is complexity and this being a big project. And one of the things I was involved with several years ago was a large project, a large mining project in Madagascar. It was a capital project that cost about $5.5 billion. It had international partners. That's complexity, and building in Madagascar and being one of the few industrial sites, it was very, very complex. And as we got through it, we had our challenges with budget and schedule. And at the end, we went to a company called Independent Project Analysis. And these are a New England consulting company that looks at project delivery, and it looks at mega project delivery especially. And what it does is it looks at the success rates of mega projects. And mega projects are not overly successful. Most of them have challenges with budget. Most of them have challenges with schedule. The other thing that they found in their analysis and in looking at projects was whether they were successful. So they could have met the project management mantra of being on budget, on time, and meeting the scope. But in the end, were they really successful, or did they meet the stakeholders and the owners and the participants? Did they meet their goals when they were done? And one of the things they found is quite often they didn't. And so what they did, or what IPA has done, is they've developed a project delivery model that says this is really important to look at what everyone's goals are and what everyone terms as what is success. And that has to be done very upfront. It has to involve all the stakeholders. And then what you do is, once you understand what everybody's success criteria are, you can shape the project, and you'll hear us talking about shaping this project. And you can shape the project so that everybody, all the stakeholders that are involved, can say at the end that it's successful. And that's the stage we're in right now, is doing the shaping. And so you can look at the IPA website and make sure you find one that doesn't talk about beer. It's independent project analysis. It's that IPA. But they talk about some carbon capture projects that they're working with. But project shaping equals project success. Complexity must be managed. It can't be simplified. Crystal clear business objectives, the success factors, what makes success, have to be upfront and have to be carried through, because there's going to be, along the scope, there's going along the path of the project, there will have to be accommodations made. There will have to be changes made. But it's always important to understand what that crystal clear business objective is, so that when the changes are made, you maintain the objective. So crystal clear business objectives. Working with stakeholders, aligning stakeholders, educating them, that's part of this series. Involving them. Establishing a stage gate process so that the project doesn't run away on itself. Sometimes in a project, the best way to end it is just finish it. And that's what and when you do that, you question your chances of success suffer. Set up cross-functional project teams, and the other key thing is communicate early, often, and widely. So communicate. It's the real estate term. Location. So we're trying to do this. And part of this is a great outreach to our stakeholders and asking them to be involved, invest time, money, and effort into this project, because we believe there'll be valuable insights for all parties. It's a robust study plan featuring those stage gates that are so essential. We're going to engage skilled and experienced professionals. It talks about climate change. It talks about decarbonization. We're setting up with a project structure, and we'll talk more with our stakeholders about that. Being part of the communication plan. And this will really set up growth enabling infrastructure for downtown Hamilton redevelopment. And it's a cost-sharing research model. So that's where we're going. That's one of the things in the next few weeks. The stakeholders will meet up. We're going to reach out to our stakeholders and get involved. If you're on this call or on this video conference and you want to be involved, please reach out to us. We want to talk to everyone. We want this to be a broad supported, well-supported initiative. We want success. We want to hear what everybody's criteria for success are. Next slide, please. So our vision is to decarbonize building heating in Hamilton. We believe there are certain strengths. HCE has been operating thermal networks since the early 2000s. This is aligning with the Hamilton's Community Energy and Emissions Plan, which I believe will be brought to Council in the first quarter. And we've had high interest. We've built on the study that the Chamber of Commerce and TAF sponsored. This has long-term impact: decarbonization, environmental, public health, economic, energy security, social license. These are all things that this project brings to mind and brings in place. We're talking about a phased implementation. We're looking very similar to what the Rotterdam example, where the line will be brought out. One of the things, I think the note from the Rotterdam example was they were talking 40 kilometers from Rotterdam to The Hague. We talk about 3 or 4 kilometers or 5 kilometers from the bayfront to downtown, and we think that's a long ways. Well, apparently the Europeans don't think it's a long ways, and it can be done. So these are all things this is what we're building on as a project to success. And just to close is why, back to the why. Well, right now, our downtown energy system heats and cools about 2.5 million square feet of buildings in downtown Hamilton. And our carbon footprint is about 6,000 tons of CO2 equivalent per year. We look at the waste heat potential, the residual potential from industry. And that And we looked at, and the earlier studies identified 200,000 tons of carbon that could be saved. So we look at that and we say, well, if we're only at 6,000, we can make our system carbon neutral. But we can also, just doing some simple ratioing, enable another 80 million square feet of buildings in Lower Hamilton to be carbon neutral. So we think this is very important, that it's, yes, it's complex, yes, it'll be transformational, yes, it's going to take time to prove it, but we believe it's worth it. And I think that's our final slide. So thank you. So I'll turn it back over to Peter. I think we've 10:59, we're on time. With questions, will have to be questions we'll address in the chat, or please email us. I'd like to thank everyone for attending. So Peter, do you want to wrap it up, please?
Yeah, thanks, Dave. That was an impressive performance from your side. Great presentation, and I hope everybody got the feel. We tried to convey, and it's hard to do these sessions, particularly online. We wanted to convey as much as possible in examples, in references. And I think, I mean, I've been working in this industry for many years, and forgive me, John, the technical side, and John Rathbone is the easy part. To get people together and to join forces and actually agree on this is really hard. And that's why I think it's a very, very strong initiative that we see in Hamilton under the leadership of Richard, Jeffrey, and Dave, and the rest, that you actually are focusing on the stakeholder. And I hate the word management, because you don't manage your stakeholders, as you don't manage your customers. You involve them, you engage with them, and I think that's exactly what you're doing. Really brilliant. Congratulations to that approach, and we look forward to seeing you all next. We'll have a conversation with David and Richard, and when and how, but I think we have a date, but let's not, I will not spoil that today. I'll come back on that. Thank you everyone for joining us. I hope you enjoyed it. You will have the recording by tomorrow. Have a good day in Canada. Here is late night in Sweden now. Well, not late, but it's evening.
Thank you.
Thank you.
Thanks, everyone.
Thanks, everyone.